Welcome to another session of Computing at Home. Today we're going to look at logical operators. But just before we do that, I think it would be a really good idea to look back at some of the work you did last time around when we looked at functions with parameters. Remember, we looked at a simple piece of code, say hello. The word say is the function. The word hello is the parameter. You then had a go at coding your own pizza, and we saw some wonderful examples of delicious looking pizza through code. When you change the parameters or the ingredients or depth of the pizza, your code creates a new pizza. It was exactly the same when you came up with your own version of rock, paper, scissors. Changing the parameters can make the whole experience a new one, as we can see in these great examples. Now today we're going to look at logical operators. These are closely related to conditional statements. If you remember, a conditional statement dictates a program's flow, and operators define when a condition is met. So you may remember we made flowcharts of jam sandwiches and had to decide if we had enough jam. Well, today our primary operators are and, or, and not. Do you remember when we travelled to Anson Road to look at the traffic lights? Well, this is a great example of using logical operators in everyday life. When the red person is on the traffic lights, we stand still, but when the person goes green, we cross over. However, that isn't all we do. Even though the light is green, we still check if the road is clear to cross. There may be a cyclist riding through the lights or a police car coming along the road, flashing its lights. If we code crossing the road at the traffic lights, we would say, if the green signal and the coast is clear, cross the road. And so this is the symbol for and in our code. In this puzzle from Swift Playgrounds, you can see where we may need the logical operator and the not operator, and this is the symbol for not. First of all, byte moves forwards. If byte is on a square and there is a gem, byte must collect it. However, what does he do if he is not on a gem? In the very next square, it's blank. And this is where we use our knowledge of conditional loops to help us. Remember how we looked at the jam sandwich and whether there was enough jam? Well, in this particular case, we need to say that if he moves forward and he is not on a gem, then he must turn left, move forwards, collect the gem, turn left, move forwards, and turn left. Else, if he is on a square with a gem, he must collect it. Now, the not operator is tricky because it requires you to think of the opposite of what needs to happen. In the story of We're Going on a Bear Hunt, we can think about the use of not and. It's a wonderful book, and the first part of the story sees the family come across some long wavy grass. If they can't go over it, and if they can't go under it, they have to go through it. And in code, this could look like this. We would tell our characters to walk, and if not on long wavy grass, they keep walking. Else, which means if they do come across long wavy grass, they should go through it. Of course, we'd never really read a book like this or code a book like this. Can you imagine? We're going on a bear hunt and we're going to catch a big one if it's a beautiful day. If not scared, go on the bear hunt. Uh-oh, long wavy grass. If long wavy grass, not long wavy grass, go over it. Not long wavy grass, go under it. Else, go through it. It's a crazy way to write a story, but pause the video and see if you can carry on the story speaking in code. What happens when they come to the water or the mud or into the cave? Perhaps you could record yourself telling a coded version of this story or another one of your favourite stories. Now, the game Simon Says is an epic way to look at code. You may have played Simon Says thousands of times, but I bet you didn't realise you were coding. The code looks something like this. If not Simon says, do nothing, else do Simon says. Now this code literally means that if the leader does not say Simon says, you should not do anything. However, if you hear Simon says, then you should act. It's such a simple way to introduce code. So just try pausing the video and playing Simon Says, or just play a game after the video. Playing Simon Says for 3 minutes every night might improve your computational thinking. Right, time to give you a new job. Today you are going to design a quiz about your favourite food, subject or hobby. When people create quizzes, they actually go through a lot of programming steps. Even a written quiz uses operators, conditions, variables, functions, and functions with parameters. We call all of this computational thinking. Just because it doesn't take place on a computer doesn't mean you're not thinking like one. In Swift Playgrounds, you can use the Answers Playground to explore how quizzes create code. Your challenge today is to create a multiple choice quiz. Take a look at this multiple choice question. What is the capital city of England? It has 4 choices: Edinburgh, Cardiff, London, and Belfast. If we select the correct answer, then we progress to the next question, or we score points. If not, then we lose or score 0 points. Making this kind of decision uses your and, or, not, if, and else coding knowledge. It can take time to construct a good quiz, so take your time. You can upload your quiz to Google Classroom or your learning platform once you've finished. And that's all for this week. We have just 2 sessions left before we complete the Computing at Home series. And next week is all about while loops. And in that session, we'll be looking at how playground games are brilliant examples of loops. See you next time.